Okay, here's our topic. Heat of solution is when something, how much energy it gives off or takes in when it dissolves in a solvent, typically water. Neutralization is when the one we're going to probably see most often is acids and bases. Here's our objective. All right, we want to use calorimetry. That's like this thing. You can't really see the chamber where you have energy released or absorbed to measure how much is gained. That's our objective. Now, it's really important. You got to know this by heart. All right. And this is going to allow us to do a bunch of formulas. And I'm going to go over the two main examples besides metal into water, which we did in a previous video. Okay, the first law is basically this. Your heat loss is going to be your negative heat gained. All right. You could see that as instead of heat, you could say Q. That's what we're going to do. And this is often going to be the system and the surroundings, all right? And there's going to be two examples. The first we're going to go over is the dissolution of a salt, or the dissolving of a salt. That's where you're going to take a salt and you're going to put it in some water or solvent, all right? And the heat that the salt or the system gives off or takes in is going to be negative of the heat that the water absorbs or provides. So this does not necessarily mean exo or endothermic, all right? And this system is the energy related to the salt breaking down and then reforming in its in the solvent, all right? You could also look at this like these, okay? And then you're going to substitute into this. Your mass is going to be your water and the salt, and your CP is typically just going to be water. The temperature of this is what's going to happen to the water, the change in temperature, but your mass is going to be the two of them added up because they're both in the system being warmed. The second example is the neutralization. Now we just take an acid and a base, we put them together, all right? Same thing, your heat loss is heat gained, all right? The amount of the heat of the neutralization is what this is going to absorb, all right? And it's very similar in that the masses are going to be the mass of everything together, water and all of this added up, and your CP is typically just water, all right? Okay, now, here's a sample problem, all right? I take some water, all right? This is about 50, a little bit below 50, and I went with 50.5 grams, all right? And then I put it in a styrofoam cup. All right, you notice this is double styrofoam, wicked awesome. And I put in the thermometer in there. I add a stir bar, all right? And then I take a reading of the system and the surroundings, and I get 22 degrees Celsius, all right? Then I measure out, this is calcium chloride, so I've got 1116 grams of it. I add that to my calorimeter, and then I watch what happens. Look, it gave off a lot of energy, all right? And this calorimeter would also have a lid on it, all right? You'd have a lid on there. Keep any heat loss and heat gained into the surroundings, all right? Or heat escaping into the surroundings in this case. And so there's my final temperature, all right? Now I can use this to solve for how much heat of solution or heat of dissolution, and that's what I'm going to do, but I'm going to do this on paper. So I want to know how much energy it gives off, heat of solution. All right. Now I needed to know how much mass I had, all right, of my calcium chloride, and I'm going to convert that to moles. So I've got that many moles, and I need to know how much water I had and the temperature change. And I had 50.5 grams of water, and the temperature change was about 19 degrees Celsius, all right? And that's the specific heat of water that I'm going to use. Now, my heat loss is going to be my heat gained, or the heat of solution is the negative heat of the surroundings, all right? And then I'm going to plug these things in, where my mass is going to be that's kind of faded, but my mass is these two added up times this times this. All right? So I plug those in, 11, there you go, all right? And I'm going to get that, all right? When I multiply those all together, I get that many joules, all right? Now this should be negative. All right? And then to get mole, I divide this by how many moles of calcium chloride I used. That's how many moles I used. And so I get this. All right? And then to convert that, it's 49 or negative 49 kilojoules per mole. All right? Now I looked up the actual value, and it's negative 83 kilojoules per mole. All right? So I got a really large percent error. Chances are I didn't use enough calcium chloride and didn't use enough water to release, but and maybe that's how you would do it. All right. Now, one thing, this would be what the equation would look like, and that 48 or 49 kilojoules would go there. All right. And that's why, since it's a negative, it comes on the right-hand side. All right. And that's how you would do it. All right. I hope this has been helpful, and I hope you have a good day. Bye.